Good morning, class. This is Controls 1. We will be covering the lesson topic today will be manually operated devices. We'll be covering material in Chapter 2 of our motor control textbook, and we are going to be building on some of the topics that we talked about last week, and definitely getting into some of the symbols that we will see in those ladder diagrams that we also discussed in week 1. So I'm going to put my PowerPoint on this video, so I'm going to voice over it so that you guys can follow along with me while you're at home studying. Okay, so the lesson objectives for this class are to identify and describe the components of manually operated devices, and also identify and discuss the functions of signaling devices. Your textbook is going to refer to these as input devices and output devices, which may be a little early in our terminology because that relates more to PLCs. And as we build on this motor control subject and in our fourth year reach our PLC class, it's good to think of these as input devices and output devices. So again, this is just building for what we hope to achieve in our 8th semester of the apprenticeship. Okay, so again, I said that the focus is going to be on Chapter 2 in your motor control textbook. So if you guys want to follow along as I'm describing some of these slides, a lot of these pictures are snipped right out of your textbook. All right, input switching devices. Just a fancy name for a switch that is going to control a load. It could be controlling a relay coil, energizing or de-energizing. It could be a light fixture that we're energizing or de-energizing. There are many other output devices that we'll discuss here later, but just think of input switching devices as a mechanism that is controlled by a human operator. So somebody actually has to physically turn these devices either on or off or press the push button to get the loads to change state. The most common types of input switching devices that we'll use are push buttons and selector switches. And you're going to see a variety of different types of push button and selector switches. Like here in this next slide, I was just trying to show you guys that you're going to come across different devices. And we're talking generically about those devices. Remember back from lesson 1, we discussed the difference between NEMA and IEC. Being different standards for manufacturers to follow when they're creating this equipment that we use in the electrical industry, and that typically we will come across mostly NEMA style equipment here in North America, whereas you'll typically see the IEC used a lot more in Europe. But both of these push buttons here, maybe a little different style, but they both are achieving the same thing. Again, making or breaking current flow to a load. To understand these input switching devices, we have to know the main components that make them up. The first of these main components is the operator. This is the part of our push button that is physically pressed, and it's used to change the contact position of contacts that are typically located on the back side of that push button. So when you think of our operator, it's going to be that piece of plastic that has a plunger attached to it, typically spring-loaded, depending on what type it is. that we press. And again, what it does is it opens or closes sets of contacts. The next part of our main components would be our poles. So inside of that, or on the back side of that push button, you're going to have contact blocks that attach these contacts to your operator. And you can order these for many different styles and configurations, where you may have one set of normally open or normally closed contacts. You could have multiple sets. And again, each one of these circuits that we're turning on and off is going to be controlled by a pole. And it'll make a little bit more sense here in these next upcoming slides, so hang tight. And then throw is going to be which position that those poles are currently in that state. So our throw will be the conducting position associated with the pole. You can see here, this is an example. This is like a cutout of a toggle switch that you guys may come across. Usually a pretty cheap switch. And on the back side, you can see on the opposite side of the operator, you can see 3 different terminals, and they're labeled A, B, and C. Here, let me turn my pointer on. That's A, B, and C here. And the difference between these two is that they're thrown in different positions right now. So you can see between my B pin and my A pin, I've got a normally open switch. Between my B pin and my C pin, I would have continuity. We would say that that would be closed. So this must be in the not activated state. And down below here, there is, this would be the symbol for this single pole double throw. And again, this is in a not activated switch. On the right here, this switch has been activated. You can see that the position has been changed. And now we've got continuity between B and A. So if I had a, let's just use a pilot light as an example. If I had a pilot light hooked up to this, between B and A right now, I would have my pilot light that was hooked up to A would be currently on. And in the not activated state, it would be off. So again, this here would be my operator. This part here is the pole. And then these are the number of throws that this pole can be in. Something that you're going to need to know is the NEMA symbol for that. You can see the normally open. This is just a single pole, single throw switch. Normally open is on the left, normally closed is on the right. And they're also showing in that top illustration there the IEC symbols for that. They look a little bit different. And we're not going to hold you accountable for remembering the IEC symbols, but just in case you guys ever come across some drawings that have IEC symbols on them, I want you guys to be able to understand. So not that difficult to make that correlation between NEMA and IEC. Below you can see a single pole double throw switch. So that pole can be in one of 2 positions. That would be the top position and the bottom position. You can see there's only one pole inside of here. So that's what makes it a single pole. And again, double throw because it can be in 2 positions. The second illustration here is a double pole, double throw. So that operator then controls both of these poles at the same time. Typically you would see something like that used a double pole operation for a 240 volt piece of equipment. I used to have some lights in my garage that were had a multi-tap ballast inside of them, and at 120 volts they drew like 20 or 25 amps. It was more than the amount of power that I could provide to them from my sub panel in my garage. So what I did was I went up in those light fixtures and wired them for 240, and I had to get a double pole single throw switch. So a little bit different than this double pole double throw. It only had one contact position, kind of like this top symbol here. But an example where you'd see a double pole switch. And then typically a 3-pole switch would be used to make or break 3-phase equipment. And you'll see a whole bunch of different ones in between. Input switching devices can come in 2 states, momentary and maintained. What that means is in a momentary switch, when I, the human operator, go to press that switch, if those contacts change when I'm pressing that button down and go back into its original state, which would be open after I release that, that would be an example of a momentary set of contacts, whereas a maintained set of contacts would be I press that push button in and it remains in that closed state until I physically, there may be some sort of a lever where I have to pull it back out to get them to change to its normal position. So momentary, again, I press it, it changes state, and as soon as my finger comes off that push button, the contacts go back to normal. Versus maintained, I press it in, the contacts change and remain in that position. A lot of times you're going to see maintained set of contacts used with emergency stops. And I know we're not in our classroom right now, but all over my motor control classroom, I've got E-stops. And each one of these E-stops is what we call a maintained operator, so that at any point, during our labs, if something unsafe is going on, I can press that maintain switch operator, and what it's going to do is it's going to open up and it's going to remain open. It's going to kill the power in our classroom. So again, you'll see the E-stops used typically with maintain operators. This slide's also showing a mushroom style push button. We're going to talk about the different types here in a minute, but I wanted to point out the NEMA symbol for a mushroom style push button. Normally closed, the terminals, so the poles are resting on the bottom side of these terminals here. A normally open would just be on the top side and not resting on those terminals, just like we talked about with our normally open push button symbol back in week 1. The mushroom style, they typically show with this little arc here, this on the top of the push button, just to show you that it's the mushroom style. This slide here was to let you guys know that you typically have to order these contact blocks. When you're ordering this equipment, the operator and the contact blocks not always necessarily come together. On some types of equipment they may, but more than likely you'll have to order those separately, and you're going to have to when you're ordering that type of equipment, you're going to have to understand that you can get these contact blocks in many configurations. I would say probably the most common you'll see is where they've got one normally open set of contacts and one normally closed set of contacts, but that's not always the case. Again, you're going to come across a whole bunch of different manufacturers that have their own type of contact block that I'm sure that they're going to push out. So just again, it goes back to having a good understanding on the number of pulls and the number of throws when you're ordering those. And something else you may want to ask is that do I have the correct operator to make these contact blocks work? So you can see this would be what looks like a momentary push button. I can tell because of this spring release inside of here, so that when that operator is pressed down, you can see the continuity path would be from here. What would happen is it would open up, and this top set of contacts, which we would typically refer to as normally closed contacts, would open up and it would break the flow of current, where these bottom sets of contacts here, when this operator is pressed, would allow the flow of current, because this little bar inside of here is going to drop down and connect these two terminals. Something else I failed to mention was that when we talk about sets of contacts, the positions are referred to as, let's say you just pulled this out of the box. When I say normally open set of contacts, I'm referring to the contacts without pressing that operator down. If I was to take a resistance measurement between the two, I would read over the limit, OL. Very, very high resistance, because it's the resistance of the air in between those sets of contacts. Whereas my normally closed set of contacts, again, not pressing the button, I would read relatively very, very low resistance, like 0.2 or 0.3 ohms, a very good conductive path. And those are referred to, again, as out of the box or not activated state. Here are a few different styles of input switching devices. You can see some of these have letter A has the extended operator. Maybe that's something that you would use for maybe a stop station, because it looks like it's got the extended operator gives you the availability to, press it in a little bit easier, versus like B and C, the guarded and the flush operators, where you'd really have to make a point to make sure that your finger was right on that operator to get it to change. Some of these, like the guarded operators, some of them are even keyed, so you may need a special key to activate that switch. And then, most of the ones that we're going to use in our classroom are like this D, where it's a flush, or sometimes you'll see the extended with these bolt-on contact blocks that go onto the back of our operator. Here's the symbols again for a NEMA push button, normally open and normally closed. I just wanted to point out our normally open again is on the top side of those terminals, and our normally closed set of contacts is resting on the bottom side. I like to think of it as if I was to press this push button down, I'm the human operator pressing this down, this contact would then close, allow continuity, versus my normally closed, I'm going to press this down and these contacts are going to open up. Something else I wanted to point out was an HOA switch, hand off auto. A lot of times we'll see these used for lighting control, typically installed in any commercial application, anywhere that's got big parking lot light systems, and you'll see a handoff auto switch. And we're going to focus primarily on this specific device next week, so I'm not going to really jump the gun on it. But I wanted to show you guys that in the auto position, you can see that this switch is turned to the right. The arrow is pointing to the right. So the auto terminals are going to be associated with these bottom two here. When I'm in the hand position, my switch is thrown to the left. You can see that that arrow is pointing to the left. And now the associated contacts would be these top sets of contacts here. And then the bottom here, in the off position, there is no continuity between the top set or the bottom set. And you can tell because the arrow on my diagram there is showing that it's in the off position. Here's the NEMA symbol. So typically all of these input devices, they're used a lot of times to control these output signaling devices. So yes, they're also used, to start, motors and maybe signals to PLCs and automated systems. But what we're going to do in class is we're going to have you guys use these input switching devices to control output signaling devices, or typically you'll see pilot lights and beacon lights. You can see here's some stack lights. These are like what we have in our classroom. There's also pilot lights that are located on the front of our control cabinets that we'll use. All examples of output signaling devices. What an output signaling device is it's used to get a operator's attention. It could be, the conveyor belt's down, so I want to have some sort of a flashy horn strobe or something that lets the operator know, hey, I have to go check out, why is this system down? It could be, production's normal. I've got a green light letting you know that, the machine, the plant's running fine. So, we use these output signaling devices for a multitude of different applications. The most important thing that you guys should be paying attention to when you're wiring these devices up are the control voltage that they use or consume. Each one of these, again, you can order for different voltages depending on what your system uses. Common systems are 24 volts AC, 24 volts DC. In our classroom, we're going to use 120 volt control, AC control. So you're going to see a large range. And even in this class that we have in our apprenticeship, we've got different devices that use different voltages. So you got to pay attention to the control voltage. So make sure that when you unbox it or you're hooking it up, that you know that it's the control voltage that you're using. Let's go back to the slide. One more thing I would also like to point out is let's go back to week 1. One of the rules that we learned was that we could not wire, like if we were using those pilot lights, we could not wire them in series. And that's because they won't operate properly. So back to just really wanted to hit at when we say one output signaling device per rung or one load per rung, that's because we do not want to have voltage drop issues that occur when we put both of these devices in series. Just like you would know not to wire multiple lights in a house in series, because the more you put in series, the dimmer those lights are going to get. You don't want to, the same rule applies for motor control equipment. So again, just really hitting that. Make sure that they are not in series, that when you want to put multiple lights on, we're going to put them in parallel. We can still use those same input switching devices to control 1 or 2 or 3 lights. We just have to make sure that they're in parallel in those rungs. All right. Last thing I wanted to talk about that your book mentions is troubleshooting. It's really important that you guys, when you begin troubleshooting, that you're paying attention to what you're getting into. Obviously you're going to be working, or you're most likely going to be working around a live systems. So that right there poses a threat. Also, if you disconnect the wrong wire, or you pull the wrong switch out, this could potentially shut down a plant. So really make sure that you're paying attention to your control drawings and that you're confident that you're making the right moves. While we're troubleshooting, really it comes down, especially with manually operated devices, it comes down to two problems. A being an operator problem. So if an operator has failed, the contacts will remain in one state and they won't change. So let's say I'm using a selector switch, or I'm trying to switch this thing to the right and to the left to control my load. If the light or whatever my load is staying energized the whole time and not going off, that could be an operator. That mechanism could be broken in there. Sometimes they're plastic, so they'll snap. So that would be A. Versus B, contact problems. You'll see a lot of contact problems with input switching devices, where you're trying to control too large of a load, and what happens is there's not a lot of space in between those contacts. Everything's real compact, and what can happen is those over time, if you're switching a real large load, those contacts can weld themselves shut, so that it would look like you're not able to control the contact position, when really it's arced and welded itself closed. Also, some other contact problems would be loose connections. Loose connections, you guys know, is going to add resistance to my circuit, which could cause heat, which could cause insulation to break down. Also, it could cause corroded contacts, could cause some excessive resistance. That would, again, that added resistance in that circuit could create such a resistance in that circuit where your output device may not work properly. So, make sure that your connections are real good connections, nice and tight, and that none of the contacts are corroded. That's something that you can just visually look at typically and be able to spot without, having to turn anything off or on. So just be really careful when troubleshooting, because you could potentially shut down an entire process. All right. So before I leave you guys, I want you guys to look through Chapter 2, look at all the different symbols. Anywhere you see NEMA, you will be held responsible for knowing those symbols for push buttons, selector switches, and in the handoff auto. And then what I'd like for you guys to do is, I would also like for you guys to create a ladder diagram. I know this is really basic, and we're going to build it when you get back to class. I would like you to have a ladder diagram ready to go that shows when a green push button is pressed, a green pilot light turns on, and when a red push button is pressed, a red light will turn off. So it goes back to having a good understanding of normally closed versus normally open, and which one of those, which contact position do I need to use to turn the lights on or off. So again, create a ladder diagram, 2 rungs. When a green push button is pressed, a green pilot light turns on. The second rung, when a red push button is pressed, a red light will turn off. All right, guys, if you have any questions, make sure that you comment on that forum that I posted, because I'm sure that somebody else is going to have the same question. So I'd rather just answer it once on that forum. All right. Make sure you guys are doing your homework and, checking Moodle pretty regularly. Hope to see you guys soon. Hopefully this is just a temporary thing and that you guys are back in class shortly. All right. Take care, guys.